All right, hey guys, we're going to take some notes in your notebook that have everything that you need to know about sequences. This should help you for your test. So if you guys can open your notebook to the title page, and we're going to make some notes. So on your title page, you can put your page number, so whatever number you're on, and then title is just, you can just call it all sequences. Sequences, just put all maybe, and then lesson, you can just put module 9 is fine. Okay, so that can be your title page. Once everybody has that, we can continue the video. All right, so if you go to that page in your notebook, go ahead and write sequences at the top, and then I want you to split your page and write arithmetic and geometric. So you can pause the video, and then as soon as you are ready, push play as soon as you have this much copied. All right, so let's start by reviewing arithmetic functions. First thing I want you to put is arithmetic functions or arithmetic functions are like linear functions. Okay, so they are like linear. So if you can remember that, then it will make the rules much easier. So if I have a rule, you can write this one down, 3, 11, 19, ... Clearly you can see it's adding 8 every time. Okay, so here's some things about arithmetic sequences. They have a common ratio, or not a common ratio, a common difference. And that's like what you're adding or subtracting by. And again, they relate to linear functions. Okay. So you have to be able to write an explicit rule and a recursive rule. So let's start with the explicit rule for arithmetic sequences. So that's where you can try to find any term in a sequence. So the explicit rule looks something like this. I like to think of it, so you put a to the n, so to find any term, you can take what the common difference is. It's kind of like the slope, and I'll put 8 times whatever term number I have. And then I need to find, if I kind of relate it to a linear function, I need to find the 0 term. So if I went backwards 8. Okay, if I went backwards 8, I would end up with -5. So I'd put plus -5. Okay, that's one way to write the explicit rule. Okay, there's another way to write it, and it looks like this. So again, to find any term, you can take the first term, which is 3, and then you can add the common difference, which in this case it's 8, times n minus 1. Now, just a reminder, these two things are going to equal each other. They give you the exact same thing. So if you want to just put a couple little notes here, underneath here, this is the first term. So if you're wondering where to get it, this is the common difference. And then n is whatever term number you're trying to find. If you're trying to find the third term, plug in a 3 there. If you're trying to find the fourth term, plug in a 4 there. All right, so make sure you get that copied down for the explicit rule. Okay, then just skip a line. I can't fit it all on one page, so I'm just going to go below again. And now let's go ahead and write the recursive rule. So that rule is where if you know the term before, you can find the next term. So if you know, like, you have 5 to start with and you're adding 3, you can find 8. And then if you know 8, then you can find the next one. So that's the recursive rule. So for that same sequence, and again, I'm just going to put it up here so I remember it. So for that same sequence, for the recursive rule, you always have to tell me, like, hey, what was the first term? Well, the first term is 3. Then to find any term after it, you take whatever the term before was, and you add 8 to it. So this would be my recursive rule. Now, if you want to make a couple little notes here, this is just whatever the term before equals, or the previous term, and then you're adding 8 to it. And then you always know the first term. Okay, so I'm going to even just put another example if you can fit this on yours, like below it. So below recursive. So you have the explicit rule, the recursive rule. Now let's actually give you one where you might have to use it. So I might give you an example where I say, okay, hey, a to the first is 10, and then the recursive rule is to find any term. I'm going to take the term before it and add 2. And I might say, hey, can you find the first 4 terms? So you should be able to do that by knowing, hey, the first term is 10, right? You get that from there, and then you're just adding 2. So I'd say, oh, 10, 12, 14, 16, dot, 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 dot. So that is an arithmetic sequence. Those are the things you would need to know about it. Let's maybe do one more if you can fit that on your page too. So another example, I'll write down here, is if I just give you this rule, a to the n equals 5 plus 3 to the n minus 1. This is the explicit rule, and I say, hey, can you find me the 7th term? Well, all you would have to do for that is plug in a 7 right here and then work it out. So for n, I put a 7, and then I just work it out. So if I was doing this, I'd say, okay, 7 minus 1 is 6, times 3 is 18, plus 5 is 23. So my 7th term is 23. So now let's go to our geometric sequence. So maybe I have 4, oops, I need a pen, 4, and then 12, 36, dot, dot, dot. So first thing you would want to do is find the pattern. Obviously, it is timesing by 3 here. Not obviously, but hopefully you can find it's timesing by 3. So some things about geometric sequences. They have a common ratio or multiplier. Okay, I'll even put multiply in parentheses. They relate to exponential functions. So if you remember that, it should be relatively easy to come up with the rule. Okay, so let's start with the explicit rule. So I'll just come down here and write explicit. So that's for if I said, hey, can you find me the 20th term? Then I would use the explicit rule. So 2 ways you can come up with this rule. The way I like to think about it is if we relate it to exponential functions. So I might say, okay, y equals, or not y, sorry. Let's put a to the n equals, I'll erase that. So a to the n equals, okay, I know my multiplier, so I'll put that 3 to the n. All right, then I just kind of need the starting amount. So if I think back, like to the 0 amount, if I do 4 divided by 3, that's 4/3. That would give me my explicit rule. Now the other way to come up with it is like this. We have a to the n, and then you can do the first term, which is 4, times the multiplier, which is still 3, and then to the n minus 1. Now you're probably like, well, those look different, but if you plug in, like, you know, the third term, if you plug in a 3 right here and here, you'll get the exact same thing. And I went through that yesterday. So there's your explicit rule. And then actually I just thought of something. We should probably put a couple little notes on here. This obviously is the first term, if you want to put that, a little arrow there. And then this is kind of tells you, like, that's the term before you do n minus 1. The n is the term number. So if I'm trying to find the 5th term, plug a 5 in there. Okay, and the 3 is obviously the multiplier. Now if you like it the other way, again, this is still the multiplier. And then this is kind of like the starting, like at the 0 amount, if you want to put that. So if you can use either of those rules again, but I want you to know how to use both of them. Okay, so let's keep going beneath that and, you know, skip a line. And now let's put the recursive rule, which I think this one's actually easier to write. So the recursive rule, again, if you want to find the term before. So again, our rule is 4, 12, 36. You don't need to write that down again. I just needed it on this page. So you always say, hey, my first term is 4. And then to find any term, I take 3 because I was timesing by 3. So I take 3 times the term before, the previous term. So again, this is my first term. This is the previous term. And this is my multiplier. So there's my recursive rule. So let's do an example now. So I'll give you a second to get that down if you haven't yet. So an example would be if I gave you this rule, I'll say a to the first equals 10. And then the recursive rule is 5 times a to the n minus 1. So then that tells me, hey, like I know my first term, it's 10. And then I'm going to take the previous term, just times it by 5. So if I have 10, if I times it by 5, I would get 50. If I times that by 5, I'd get 250. And then I could keep going from there. Okay, so there's one example. So below there now, let's do another example. And this time, I'll give you an explicit rule for it. So I might give you this. A to the n equals 2 times 4 to the n minus 1. And I say, hey, could you find the third term using that rule? Okay, so I've got my rule. I want to find the third term. So all I have to do is plug in a 3 where the n is. Okay, so if I do that, 3 minus 1 is 2. So I end up with 2 times 4 squared. Well, 4 squared is 16 times 2 is 32. And there is my third term. So I just wrote a recursive rule, wrote an explicit rule, and then did 2 examples with it. All right, so make sure your notes are updated and you have that in your notebook. I'll also update my notes in Notability Online, but you can watch this video again if you need to catch up on some notes.